So I got an email back from Sister Cook on our question. And the only thing that she said is we have to do a QQ plot. And in the plot, you're looking to see if the data falls close to the line or a straight line. If it does, then it is normally distributed. If there's some kind of pattern or the data is all one-sided, then it's not normally distributed.
Okay. That's a bit disappointing. It doesn't really give much clarification.
No. And she did say if you have any other questions and that about the problem to let her know.
Okay.
But,
well, thanks for emailing her.
You're welcome.
Still kind of weird to me.
I know.
But luckily at least on the review test, it didn't have any questions like that. So
no.
Hopefully the real test won't either.
That'd be nice.
Yeah. Okay. Well, I feel like this practice test was a lot easier than I was expecting it to be.
I did too. I mean, I had maybe like 5 or 6, questions in that of I think this is the right answer, but I'm not sure. But other than that, I felt pretty confident.
Awesome. Cool. Well, let's just go through it then. Okay, so question 2, given a 90% confidence interval of 45, 105 for mean heart rate, which of the following is the best interpretation of this confidence interval? I'd say we're 90% confident that the true mean heart rate is between 45 and 105.
Yeah.
So what you would say?
Yes.
Okay. Question 3. So the researchers decided to construct a confidence interval to determine if the difference of the means is significant. To determine whether the confidence interval would be reliable, they created QQ plots of both random samples and see that they're approximately normal. Are the requirements for constructing a confidence interval satisfied? So I said yes, because the data seems to be normal, which is the third one.
And that one was question 2. Yeah, I did too. Sorry that they have it labeled differently on the question here, so I'm going, wait a second, what did I say?
I know. It's annoying.
Yeah.
They shouldn't have done that. I don't know why they did that.
Yeah, I said the same thing.
Okay, so question 4. Of the 4 types of confidence intervals listed below, which one is appropriate for this experiment? Confidence interval for the mean. Oh, so I said 2 means of independent samples. The third one?
Yeah, I said the same thing too.
Okay. Question 5, a researcher is interested in estimating the savings account balance of customers at large bank. She obtains the savings accounts, blah, blah, 90%, 95% confidence interval is found to be that. Which of the following would produce a confidence interval with a smaller margin of error? So I said to increase the sample size. So I think that's the last one. So obtain the balances of 90 bank customers rather than 30.
Okay, because I was teetering between that one or doing balances of only 10.
So if you want to decrease the, like a smaller margin of error, you either have to decrease the confidence interval or increase the sample size.
Okay.
I'm pretty sure.
That makes sense.
Okay. So question 6. Determine the margin of error for this 95% confidence interval. Oh yeah, so I said the margin of error was 1.960. You know what you got for that?
That one. Are we skipping a question?
No, the original question was asking what the confidence interval was. And this is just asking what the margin of error is.
Okay, because I'm like, the question 6, I did get the 1960, but for this one, and I went with a, so.
Yeah, I said A2.
Okay.
So to find the margin of error, we do the confidence level, which is 1.960, and times it by standard deviation over the square root of the sample size, which is 2 over the square root of 4, which is 2 over 2, which is 1.
Right.
So we just times 1 by 1.960. So the margin of error, I think, is 1.960. So then for 7, the lower bound, so you put A2.
Yeah, I did.
So it's 998.04. Oh wait, it says round to 3 decimal places. I don't want to mess that up. Let me make sure I got that.
Be rounding to 3 decimal places.
I just put a 0 at the end.
Yeah, the question on here has a 0 on the end of both of them.
So yeah, so then the upper one is 1001.960.
Yeah.
Okay, question 9. To assess the accuracy of a laboratory scale, a standard weight that is known to weigh 1 gram is repeatedly weighted a total of n times, and the mean of the weighings is computed. Suppose the scale readings are normally distributed with unknown mean and standard deviation of 0.01. How large should n be so that a 95% confidence interval for the population mean has a margin of error of that? So I got 38,416.
Okay, so on that one, I got 1960.
So what did you do?
So I took the 95% confidence interval, which is the 1.960, times that by the standard deviation and divided that by the 0.001.
Yeah. So I did the same thing, but then you're supposed to square it.
Maybe that's what I'm missing.
But yeah, I did the same thing and then square it, which would be 38,416.
Okay.
It was weird to go over those again. I kind of forgot how to do them.
I know, right?
Okay, question 10. So the mean area of the several thousand apartments in a new development is advertised to be 1250. A tenant group thinks that the apartments are smaller than advertised. They hire an engineer to measure a random sample of apartments to test their suspicion. The appropriate null and alternative hypotheses are let's see, thinks that they are smaller than advertised. So I think it's the last one, right?
Yeah.
Okay. Smaller than 1250. Okay. Question 11. In a statistical test of hypothesis, we say we reject the null hypothesis with a level of significance A if, so reject, so if p-value is less than alpha.
Okay. See, and on that one, I wasn't sure if it was that one or if it was if the A is small.
Yeah, I was kind of wondering the same thing, but just based on like, if it's smaller, we reject it. If it's greater, we fail to reject it. Which
Yeah.
makes me think it should be if the p-value is less than A.
Okay.
Okay. So this one I just put A, so I don't know what what it was. A group of statistics students wants to determine if students in some apartment buildings get better grades than students in other apartment buildings. They collect GPAs from an anonymous random sample of size 15 from each of the 4 different apartment buildings. The data for each apartment building are bell-shaped, no outliers, and the sample variances are nearly equal. Can they use an ANOVA hypothesis test to answer the questions?
Wouldn't that one be the third one?
Yeah, I think so. I'm going to open up real fast the pre-test so I can look at what it was. Yeah, I'm pretty sure it's me because that makes more sense to me.
Yeah, it made more sense to me too.
Okay, perfect. Okay, question 10 or 13. Okay, so for that one, I'm just gonna stop reading them all. So that one, I said type 1 error because they rejected the true null hypothesis.
That one I put a type 2 because I went back and I read and it sounded like through the question here that they rejected it even though they figured it was true. So that would be a type 2 error.
Okay, let me see. Medical researchers working on a new treatment for a certain type of cancer. The average survival time after diagnosis for the standard treatment is 2 years. So the null hypothesis is that the average survival time after diagnosis is the same for the new treatment and the standard treatment. In an early trial, she tries the new treatment on 3 subjects who have an average survival time after diagnosis of 4.5 years. Even though the sample is small, the results are statistically significant at the 0.05 significance level. Consequently, she rejects the null hypothesis. In a future study, it is determined that the new treatment does not increase the mean survival time in the population of all patients of this particular type of cancer the researcher has. So type 2 error is if you fail to reject the null hypothesis when it is actually false. So I still think it's a type 1 because they rejected the null hypothesis when in fact that was the truth.
Okay. Maybe. Okay. I could have.
I could be wrong though, but that's what I think.
Okay. Yeah, I had to reread that one several times, and I'm like,
Yeah. The type of errors are just a little bit confusing to me anyways.
They are to me too.
Okay, question 14. If the level of significance alpha is made very small, thereby making the probability of committing a type 1 error very small, what happens to the probability of committing a type 2 error? So I think it's if we reduce the probability of committing a type 1 error, we increase the probability of committing a type 2 error.
Yeah.
Yeah, I think they're inversely related. Okay, question 15. I said we reject the null hypothesis. What did you say on that one?
I also rejected the null hypothesis too.
Perfect. Okay, next question. You would like to look at the mean number of hours worked for wages per week by male students and female students. We would like a random sample of 100 for each. What is the correct statistical procedure? So that's the independent samples to test, right?
Yes.
Yay. Okay. Next one. So for this one, I said dependent sampling. And it's because if you select a brother, then you must select his sister.
Okay. And I
the
teetered
last one.
between both of them too, but then I also thought maybe independent because I thought, well, the brother's academic success doesn't necessarily depend on the sisters either.
Which is true, but the way that, so it says she decides to use brothers and sisters raised in the same home. So she decides to use only brother-sister pairs when they are next to each other in sibling order. So even though that is true, like, yeah, his achievement doesn't depend on his sisters, that's not what they're questioning. They're questioning is how they're choosing the people that they're testing. And they're testing a brother-sister. So like they're definitely related.
Okay. See, and that one was funny. I had to reread that. I'm going, no, it's dependent. I'm like, no, it's independent.
Yeah. It's the
That
weird
one.
one.
So.
Yeah. Okay, question 8. I said the first one. So when sigma is unknown.
And that one I wasn't sure if it was known or unknown. Because I put at first if it's known.
So because they don't list it in the description, I would think it's unknown.
Yeah. Okay.
Okay, which of the following is the 95% confidence interval for this analysis? Input your answers for the margin of error, lower bound, and upper bound. So I use the software for that. So the margin of error would be the upper bound minus the lower bound divided by 2. Oh, if I can get my pen to work. There we go. What did you get for your confidence interval in that?
So on that one, I got D. So 11.168 and the 15.
Like 2 and 7. Good, that's what I got. So for the margin of error, I'm getting 2.025.
Okay. Yep.
Okay. Okay, question 22. Of the 4 types of confidence intervals listed below, which one is appropriate for this situation? So I said the means using independent samples. So I said the third one.
I said the same thing too.
Sweet. Okay, so then calculate the confidence interval. So I got C for that one. So for the lower bound, I got negative 423.
I did too.
Yay. This is nice. I'm actually getting the same answers.
I know, right?
So then the upper bound's 5417.
Uh-huh.
Next question. What is the correct hypothesis test for this situation? I said ANOVA.
I did too.
Sweet. 26, calculate the test statistic. So I got C for that one, 7.978.
I did too.
Okay. The p-value, I got B, so 0.002.
Uh-huh.
Okay. Then 28. So we reject the null hypothesis. So we say that they're, okay, let me see what I put here, 22B. I said there's sufficient evidence to conclude that the bone density of at least one of the groups is different from the bone density of at least one of the other groups.
Okay. See, on that one, I was questioning if it was that one or if it was D.
Or if it was D, which is there's sufficient evidence to conclude that the bone density between all the groups are different.
Yeah.
So yeah, if you look back in that chapter,
The ANOVA says at least one of them has to be different.
yeah, exactly. Yeah, because I did this. I think we did the same thing on our quiz when we were confused about that.
I think so too.
Okay, so 20. Next question. I said dependent samples.
That one, 24. That one I thought maybe could have been a z-test too. And I don't know why I put that.
Sample z-test.
Mm-hmm.
Well, it has to be two samples because they're comparing the 90-day to the 14.
Right.
So it has to be either independent samples, ANOVA, or dependent samples.
Okay.
And ANOVA is for like 2 or more, or sorry, 3 or more. So I wouldn't say ANOVA.
Right.
So then we have to determine if they're independent or dependent. So I said that they're dependent because they check the same flight. So what they check 90 days in advance determines what they check 14 days in advance.
Okay.
So that's why I said dependent. I don't know. Do you agree or disagree?
Well, I would agree with that because, I mean, yeah, they are checking, even though they are different as far as the date. So,
yeah. I think I'm going to try the dependent. I think that's what it is. So for the test statistic, I got 1.685.
I did too.
Sweet. And the p-value, I got 0.096.
So did I.
Perfect. So then for the last one, I said that there is sufficient evidence to conclude that there is a difference in the cost of tickets purchased 14 days in advance compared to 90 days in advance.
I said the same thing.
Yay! So that's the second one. Alrighty, let's see how we did.
We got question 14 wrong.
Question 14.
That was the type errors one.
Oh, I got that one right. What'd you put?
Reducing the probability of committing a type 1 error. I put the third one.
Oh,
Maybe
so
the first
I
one.
put the first one. So by reducing the probability, so when you reduce type 1 error, you increase type 2 error.
Okay.
Because remember, we were saying that they're inversely related.
Mm-hmm.
So I'm pretty sure that's the answer for that one. And I missed 23 and 24. That's weird.
Huh.
That's really weird.
And then 28 too.
Oh, I got that one right too. Which one did you put?
That one. I put the second up, and that's why it put insufficient and needed to be the third one.
Yeah, the third one. Okay. All right, I'm gonna put this in real fast for the data for used Hummers. I'm gonna see why we got that wrong. Okay, so we use confidence interval for the difference in means using independent samples. Independent samples. Yeah, I still am getting the same answers for those. I don't know why we got that wrong.
Okay, yeah.
I guess if I try to do the long way, let me see if I can figure that out. Margin of error. Well, no, it's the same thing. I wonder if it's because I didn't put decimal places at the end of it.
Yeah, I was gonna say, I wonder if that's the reason there.
Okay, I'm gonna resubmit it and do that. I hope that's the reason, because otherwise I don't know what I did wrong there.
I know, right?
That's like one of the easiest questions.
Yeah.
I don't know what we could do differently there. Okay. Can I redo this? I hate having to redo it all.
I know.
Shoot, I just opened the exam.
Uh-oh.
Oh, I'm gonna have to do the exam. Okay, sorry, I'm gonna hang up with you and do the test.
No problem.
That's so annoying. Well, good luck with the test.
You too. See you Tuesday.
Okay, see ya.